The topic today that we're going to talk about is entropy. But before that, I want to discuss the factors affecting electron affinity because I was saying that we did not review them. So we can talk about that. So, first of all, we know that electron affinity is the energy change that is involved when electrons are given to atoms or ions. Okay. And there are three factors that affect it. First of all, obviously, it's being added to the last shell. So last shell को जो चीज affect करेगी वो इसको भी affect करेगी. तो configuration में obviously जगह होनी चाहिए वहां पे. But more than that, the values, वो value nuclear charge पे depend करती है जिसको हम effective nuclear charge भी बोलते हैं. The value also depends on atomic size or ionic size. ठीक है, जो radius होता है उस पे, क्योंकि if the radius is small, that means electron affinity जो है उसकी value को कैसे impact होएगा कि the electron that's being added, it's going to be pulled more strongly. So it's going to be bonded more strongly. And that means the energy release is going to be higher. Similarly, if it's further away, so the energy release is going to be less because the force of attraction is less. Similarly, greater the effective nuclear charge, greater the attraction that it has, again, electron affinity will be higher. So there's a larger value of electron affinity that's going to be there. So you can see that clearly electron affinity's value indicates how strongly it binds to the nucleus that you have already. And the last factor is obviously the shielding effect or the configuration, if I were to say that. The configuration involves shielding effect. कि अगर वो add कर रहे हो आप और वहां पे already there's a lot of repulsion that's coming in because obviously there's an electron cloud in which you're adding it. So that repulsion, if it is greater, then the bond that is formed, the force of attraction between this electron and the nucleus is going to be weaker. And that means the value is going to be lesser. So again, जितनी strongly वो nucleus के साथ bond होगा, उतना strongly, उतनी high उसकी electron affinity value will be. Sometimes another important point to remember in this case is whether electron affinity will be for a positive or negative. So for that, you have to see that what exactly wins. There is the repulsion that's already coming in, which is going to reduce the value or make it more positive. Because to fight that repulsion, you have to push the electron in, and that means it's going to be more positive value. And the attraction that's coming from the nucleus, that's going to bind to it. It's going to create a new force that's attracting, and that's going to make a negative, it's going to make it a negative value. So in दोनों में से जो win करता है, that gives you the overall positive or negative charge, negative sign. In the case of first electron affinity, you're adding it to the neutral atom. And in a neutral atom, you can add it, provided there's enough space available. And the attraction is much more stronger, and the repulsion is only coming from shielding, which can easily be overcome. So overall value aapki negative hi aati hai. But then the second time you're adding the electron, you already have something with an extra electron in there, which means that ion has a negative charge. और जब उसके ऊपर negative charge होगा, and you're also bringing in another negative thing, it's going to fight it, it's going to repel it. And you have to supply the energy to make it go in. And by you, I mean the surroundings. And the surroundings have to supply that energy. And when that happens, the value rises up and becomes positive delta H. So those are the values, or those are the implications on the values of electron affinity. So first electron affinity is always going to be exothermic, but the second, third, they're all going to be positive because energy is going to be supplied to add electron to something that's already a negatively charged particle. All right. So that is the factors that affect electron affinity.